In the last class, we were discussing about addressing modes, where we discussed addressing that looks like absolute, direct, and then we discussed about indirect mode of addressing that is somewhat closer to the pointer idea. Is it any doubt or confusion about that? Any confusion, or is it clear to everybody? Okay. Hopefully you could understand that. Another mode that we'll talk about is index mode. This is kind of mode that can be correspond to arrays in your normal computer programming. Let's see what does it mean actually. So the idea is pretty simple. X R I, where X denotes as the constant value and Rj or Ri, whatever it is the name of register. And the effective address then will be X plus Ri. That means X plus whatsoever is being written in Ri. So suppose if X, you are writing 4000 Ri, and at some point of time Ri has value stored 2500 in it. Your effective address will be 4000 plus 2500, that is 6500. Right?
So X is the starting address of this array.
You can say that. So we also call it offset. Right? Is it okay? Is it okay?
Yeah.
So if you want to use it like an array, you already have a value that's stored in RI. You can use different values, maybe 1 or maybe 0, maybe 4, maybe 8, and likewise. So this way, this can be used in doing the array implementation, right? Another possibility is you can write Ri, Rj. So when you are writing Ri, Rj, what the effective address will be? In that case, it will be Ri plus Rj. Then even you may be looking for a constant term, so you can write it Xri, Rj. In that case, effective address will be Ri plus content of Rj plus X, right? Is it okay?
Content of RI is a memory address, right?
Content of Ri is I mean, we are talking about effective address, so everything is a memory address. X is also contributing to memory address. Content of Ri and
Yes.
Rj is contributing to memory address. Although, I mean, you can use it differently as well, but here we are talking about addressing. So that's why we are saying that everything is effective address. I mean, memory address. Make sense?
Yeah.
So so here we can see that we have seen three kind of indexings, where first is XRI, second is RI RJ, and third is XRI RJ. For simplicity in understanding, all have been named differently. So the first one is named as index addressing. Second one is termed as base with index addressing. And third one is named as base with index and offset. So by now probably you would have understood that this is the offset, this is the index, and this is the base. You can name it differently, but conventionally or for having a common notation, we are actually representing it like this. Right? Is it okay? Another mode is relative addressing. Relative addressing is nothing but index mode only. The only difference in index mode and relative addressing is that in place of any general purpose register, program counter is used. So in place of XRI, no, this is not the right thing. We write XPC. So this is basically used in generally used in identifying the target addresses in branch instruction. Is it okay by now? Any confusion about it? Hello? Is it okay by now, or there are confusions with it? Hmm? Hello? Am I connected or disconnected?
सर इसमें पीसी क्या है?
पीसी क्या होता है? पीसी के बारे में हमने कभी बात की है क्या?
याद नहीं है सर.
क्या नाम है आपका?
अच्छा, प्रोग्राम काउंटर. ठीक है याद आ गया.
क्या नाम है आपका?
प्रियांशु.
आप पिछली बार कब क्लास में आए थे?
नहीं याद आ गया सर. प्रोग्राम काउंटर. मैंने दूसरा सोच.
अच्छा, क्या दूसरा सोच लिया था? Anyway, so any confusion about it? Is it okay to everybody, or is there a confusion?
Sir, it's okay. Sir, you should suppose if nobody answers that it's okay.
It is also possible that nobody is listening.
No, sir, we certainly are. Any doubt and we would just spontaneously ask the question.
I don't know, because either these things you have already studied or you are not listening.
Yeah, so
Because
for me, I have studied this thing in +2 because I had taken computer science. I can't say for others.
okay, so should I leave this all and move on to other things, or okay? I mean, it's anyway.
No, sir, that's for me. Other people might not have.
There are two more modes that we are going to discuss. That is auto increment and auto decrement. And then we'll finish this. And auto increment is somewhat like this, and auto decrement is somewhat like this. What does it mean? I'm just telling you in a minute. So here, I mean, these are actually the combination of two instructions. So same as this. This has instruction is EA, that is effective address, is the content of RI. And then after using this, increment RI. So when next time it will be used, it will be incremented effective address. This time the increment will happen after you have used this. And similarly in this case, first decrement RI and then keep EA is equal to contents of RI. So these are the addressing modes that actually uh, increment and decrement the values of the register. You can replace the positions of positive and negative signs. In that case, the commands increment and decrement position will change. So, for example, if you write plus in bracket ri, in that case, first increment will happen, and then effective address will be used. And so for ri minus, so first ri content will be used as effective address and followed by the decrement. So these are the increments that, these are the addressing modes that we had to discuss. Generally, these addressing modes are used, and most of the times, this actually completes the requirement. Now, let's move on to a little bit small idea of assembly language and assembler assembling process. So, assembly language you already understand. I am just reiterating that. So, what your machine understands, it only understands zeros and ones. So, the continuum of zeros and ones it understands, nothing else. But it is very clumsy for any of us to use zeros and ones. So, in that case, what we do, we use something called assembly language. Assembly language uses, you can say, commands or normally called as mnemonics. Like add, move, store, etc. So what you do, you write the set of such mnemonics along with something like name of the register or some kind of memory location or something like that. This all makes a program. This program is something that machine cannot understand. You know that. So then there is another program that is called as assembler. Assembler is actually a program that is a collection of utility programs that are the part of system software and rests in the memory of the computer. So this assembler program translate the assembly program that is called as source program. So whatsoever we write in assembly language, we call it source program, to an object program. And this process is called as assembling. And for that, the opcodes of these mnemonics is used. So opcode is nothing but the binary representation of these mnemonics. So these mnemonics will be having a binary representation that we call as opcode. Assembler actually do this kind of conversion. Right? Is it okay?
Yes.
So now let's go detail into that. So how many of you have heard about this thing? Have you heard about this? Assembler directives? Anybody has heard about it? Assembler directives
So is
or
it
compiler
like
directives?
so is it the things that describe what the particular instruction would do?
No, not exactly that. That may be termed as comment, not a comment.
Like what a move to this would do, and then the opcode would be there.
So it's not comment. Assembly directive is assembler directive is something that assembler will read. What you are saying is something that assembler will not read. So comment is a different thing. I think you are talking about comments, right?
No, sir, I'm saying like I have used microprocessor 8085, and with that there comes a list where there is all the instructions, their opcode, and what they do. So move A to B. So it would be written that this instruction does this in the list of that particular device which it comes with.
So
That
that's
is
what
what I'm comment
when
would. Yeah.
this instruction does this, when you say this, that means assembler is not going to read that. This is for your
It doesn't
understanding.
had a it doesn't had a assembly. We just have to type in opcode.
This doesn't has to.
8085 doesn't have an assembly, right? We just type in the opcode, whatever we
8085
want.
also has assembler. It's a different thing that you would not have used that assembler. You would have typed directly.
Yeah.
So, but the assemblers are available for 8085 as well.
Okay.
Yeah. So anyway, so these are the statements, or you can say commands or utility, whatever you call, that will be read by assembler, but will not be the part of object program. So for example, somewhat like this. Something similar of this kind have you seen in C programming? This says sum is equal to 200. So wherever sum will come in your program, that will be replaced by 200. Have you seen any such thing in your normal C programming or whatever programming you have done?
Yes, sir.
What do you call that?
Um, macro.
Variable assignment.
No, it's not variable assignment. Beta, variable assignment mein you declare a variable, you declare.
Like we use a hashtag to
What's your
define
voice is breaking?
word to a
Eh?
particular number.
The voice is breaking.
I am saying it's not a variable assignment. Variable assignment thing goes to the object program. Oh, sorry, object program, and it's. I mean, you write something else. So you write in variable assignment a is equal to
Yes, sir.
20.
Actually, we use hashtag define for that.
It's not this. Yeah, somebody saying something.
We use the hashtag define and then the name. Like if I want to assign everything wherever max is mentioned and I want to change it to 100, I write hashtag define max 100.
Yeah, that's right. So what do you call this? These are equivalents, right?
Macros.
Mac, not exactly macros. There is a different term for that.
Sir, preprocessor command.
Yeah, many times it is called preprocessor. But the similar thing with both the commands is neither of them is used by, I mean, these are used by assembler or compiler, but they never become the part of the object program. So these kind of statements called as assembler directives. Make sense? So we'll see. a small program where assembler directives are used. And we'll just understand few assembler directives. Here the objective is not to teach you assembler directives in completion, but just to tell you the idea of assembler directives. So let's do it. So okay, so this is actually machine address label. This is operation, and this is addressing or data information. I should not draw these lines, but just to make sure that you are not mixing one thing with another, I'm drawing these lines. And then so do you remember this hash? And then you will go for some more part of code. Probably you can also write that. And then you will write, okay, let me write one more probably. Loop at R2, R0, and then something else, and then finally return, and then end. It will start. Right? So can you see this? So up till this part, not this actually, I've drawn slightly higher. Up till this part, whatsoever written is actually assembler directive. And then here what we are writing is something that will, I mean, it will be the part of object code, object program, whatever call it, object code, right? So now let's see what is happening here. So what this directive is doing, that we have already discussed. So it is actually equating the value of sum to 200. So wherever this will come, you will replace it by 200. So if sum is coming somewhere in this program, that will be 200. Right? Now, second assembler directive is origin. So this origin tells a assembler program that where in memory to place the data block that follows. So that means you are saying that the data will be stored from a location starting from 2204. And I mean, since this has to be, I mean, stored with a data word 100, so now you are actually storing 100 there. And this is actually at 204. So you can see that you are getting address at 200. I mean, data at 204. Right? Is it okay? And further, you have given an address label this to n. So that means n is, I mean, this is equivalent to using the assembler directive n EQU 204. So wherever the n will be there, that will be replaced by 204. Then you see there is a reserve directive. So that says that the size of memory block of these many 400 bytes has to be reserved for the data, and that has to be associated with the name num1. So num1 is the block that has to be of 400 bytes, and this has to be reserved for data. Right? Then you see there is origin coming again. So now this says that the instruction of the object program are to be loaded starting at address 100. So, I mean, this is another origin. So first origin talks about the data block. Second origin talks about the instruction block. And you see that this actually ends with an end directive. So after this origin, the code starts, and the final directive you see is end. So that tells you that, okay, now you have done it with it. So, I mean, it has a addressing information start. So that is the start of code. So, so this gives you the total code block available. So I'm not saying that this list of directives is exhaustive. I'm just telling you uh, what these directives are doing. So now probably you can understand that why these directives are being used. The idea behind directives to be used is to figuring out, I mean, how to interpret names, where to place instructions in the memory, where to place data operands in the memory. So these questions will be actually answered using the assembler directives. Any confusion about this? Any question or any confusion about this? Okay, I hope not. Now,
These instructions
let's,
are not read by assembler.
these will be read by assembler, but they will not be the part of object code. So they will be actually helping in generating the object code, and that's why they will be read by assembler. And like preprocessor statements, or sometimes these are also called macro statements, these are the assembly directives. Those are definitely useful for programming. It's not comments. Comments are not being read by compiler or assembler, whatever. These will be read, but will not be the part of the object code or object program, whatever you call it. Got it?
Yeah.
Now let's move on to the process of assembling. So, I mean, there are actually multiple iterations by which a assembler reads through the code. Because a key part of assembly process is determining the values that replace the names. So in some cases, it will be specified EQU directives. And there it is very easy. You can figure out that where EQ is written, you can replace everything by that. Whereas in other cases, it is defined by label fields of given instructions. So in that case, you have to figure out. So for example, loop, you would have seen that loop is mentioned. So you have to figure out where loop was written and all that. So, I mean, in that case, it is little tricky. And generally in branch instructions, this kind of things do happen. So, I mean, assembler is supposed to compute the branch offset so that the correct address can be put in the object code. So, as assembler scans through the source program, it keeps tracks of all the names and numerical values that correspond to them, and then it makes a table that it's called symbol table. So all these values that it determine, it keeps in symbol table. So in case of branch instructions, it is many times not possible. So the simple solution to this problem is to have the assembler scan through the source program twice. So that we call as pass. So when it scans in the first round, we call it first pass. And first pass is only used for creating a complete symbol table. So it will not translate anything, it will not interpret anything. it will just go through, and whatsoever symbols it will get, it will make all these symbols in a table with the corresponding addresses or numbers, whatever. Whereas in second pass, it will do the required job. Substitute the values for all names from the symbol table. So that's why these kind of assemblers are called as two-pass assemblers. So after doing all that, assembler stores the object program somewhere on secondary memory, maybe some kind of magnetic disk. And whenever you want to execute this program, it will be loaded in the memory. So there is a program that you would have heard by now in programming that is called loader. Loader is a utility program that the job of loader is to actually load the program from secondary memory to main memory. Right? Is it okay? So this all we want to discuss about assembler, assembly language. Now let's move on to the input-output operations. So what do you understand by input-output operations? Any idea?
Operations related to printing on screen or inputting
Yeah.
values from us.
So there are different devices that are connected here and there. So maybe there is a keyboard, maybe there is a printer, maybe there is a monitor or a screen, and so many. Of course, processor is also one of the devices connected. So these devices, so keyboard has to give some data to screen. Of course, most of the times, I mean, the conditions we are reading to through processor, although there are ways and means by which it can be done directly, but so far we are talking about via only. So these kind of operations has to be performed. So how to perform these operations, that are called as IO operations, that we are going to discuss now. So the simplest way of performing such IO is known as program controlled IO. So in this kind of input-output operations, we write a program, and with the execution of that program, the data transfer happens. The problem with the IO operation is, can you suggest me what may be the biggest problem with IO operations? Can somebody suggest a problem with IO operations?
Sir,
Very
the transfer might not, the processing of the instructions might not be as fast as the processors.
The processing of the instruction will happen at the processor only. So far, we are not talking about the systems where we are bypassing the processor and performing the instructions. So whatsoever we are writing in programmed IO, that will be actually happening at processor only. So that's not. So Can you suggest a very common problem that happens? I mean, that is being
Sir, most of program input size is fixed because we have to allocate memory before running the program or taking the input.
there is no so much noise from your side, background noise. So I could not appreciate what did you say. If you can say it in a more calm and noise-free way, I'll be probably able to understand. Hello. Okay. So generally what happens? These devices are different devices by design, by nature, by construction, by operation. So the way they consume the data or the way they generate the data is different, and therefore their speed as well. So for example, if somebody is typing on a keyboard, there will be a human sitting on the keyboard that will be typing on the keyboard, and that has got certain finite and rather a small speed. Whereas the screen that is going to take that will be little fast. So there will be, I mean, and other kind of cases will also be there when device is not able to, I mean, consume the data as fast as another device is sending. So there are the difference of speeds with these kind of devices, and that difference of speed causes problem many times. So many times, I mean, the receiver swamps. It cannot. It is not in a position to consume the data that it is receiving because the amount of data that is coming, that is really huge. At least the speed is huge for his performance. Many times data is there, but I mean, it is waiting, but no data is coming. So that problem is even smaller because in that case, at least no loss is happening, but that is also causing some kind of inefficiency. So this is the biggest problem that we handle in IO operations. So for that, some kind of handshaking is needed. So generally what is done, we use certain kind of signals. So SIN and SOUT. So if we'll see the bus architecture, let's say with keyboard and display, it will be something like this. There will be a register that will be called data in, and then there will be a flag or bit, whatever you call it, SIN, and similarly there will be another register that will be called as data out, and here you will be having something like shout, as out, actually not shout. This is some kind of screen. This is some kind of keyboard. So on output, processor will send the first character and then waits for the signal from the display. That character has been received. It then sends the second character and so on. So input is sent from keyboard in the similar way. So, I mean, this actually solves the problem in a way that whatsoever data is coming, that is coming to data in, or whatsoever data has to be sent, that has to be sent to data out. And S in and S out are actually monitors, the indicators that a processor will monitor, whether its value is 1 or 0. And when it is 1, that means it is ready to receive or ready to send. So, generally, a small 2-line program will be, one is read wait, and one is write wait. So read wait will be somewhat like this: test bit, input status, okay, it will be a little complicated for you. So first, let's define read wait properly. So this is nothing but branch to read wait if sin is equal to 0. Then the next instruction will be input from data in to R1 or any general purpose register that you are actually deploying for that. Similarly, analogous program will be to the display as well, and that will be write wait. So here branch to write wait. Actually, it should be written in capitals. If SOUT is equal to 0, and then output from R1 to data out. So are you able to understand this? This is getting little clumsy. Hello? Are you able to understand this?
No, sir.
The idea is only this, that we are putting a buffer register and we are putting a indicator or monitor. You can call this control flag. So whenever processor is to be informed that a valid character is available in data in, keyboard is giving some character, this SIN will become 1. And as soon as SIN will become 1, processor will read the contents of data in. And when the character is to be transferred to the processor, when this character is transferred to the processor, this SIN will become 0. So 1 when keyboard has to send 0 otherwise. So can you understand this thing? Can you understand this thing?
Yes, sir.
Some train is coming or what? And similar thing is happening here as well. So S out is going to be 1. When display is ready to receive the register. And when it is not ready to receive the register character, it will be again to 0. So 1 when ready, else 0. Right? So these are the buffer registers and these are the status flags. So in order to perform these IO transfer, some machine instructions need to be written that can continuously check the status of flag and transfer data between processor and IO device. So whatsoever I have written is actually nothing but the part of that code that will be actually used for that. So, the exact code I'll write in a while, but there will be two small, you can say, functions or subroutines. Subroutine, although we'll talk little later. So there will be two small subroutines or functions that will be used in the uh, operation of taking the data and giving the data. Right? Is it okay? Does it make sense now?
Yes, sir. It's okay.
Everybody, to everybody, it's okay. So this is programmed IO. Another IO is called as memory mapped IO. So in that, the memory locations are generally, used. Address of memory locations are generally used for addressing some device. So you are not putting something extra. You are just using those memory locations for addressing the device. The advantage is at processor side, you don't need to have a different kind of, address or something like that. Processor will use these things as it is actually using the normal memory operations. So in that case, no special instructions will be needed from transferring the data like read wait or write wait. Simple operations can be used for that. So these are the two kind of IOs that we talk about in general. So one is program controlled IO and part of that is memory controlled IO. Is it okay? Huh? Is it okay?
Yes, sir.
Okay, so now let's move ahead. So what to discuss next after that is stacks and queues. So what is a stack? You already know. Tell me, what is a stack? What is a stack?
Sir, first in, first, last out.
Huh?
First in, last out.
No, that is not stack. Stack is something else. First in, last out, or first in, first out. This is just something that is used for taking data in and out from that. So what is a stack actually? Why it is used? What is a stack?
Sir, to give priorities for program, such as which one should go first.
Huh?
Sir, it can be used for give priorities.
Priorities.
Yes, sir.
How come priorities?
Sir, sir, assume some program has to run at last position या फिर last.
नहीं बेटा इसके लिए नहीं यूज करते स्टैक को.
Okay, sir.
Anybody else can answer?
So it's a sort of data structure that possesses that property that Ajit mentioned. It could be used in storing functions. When a function is called in any programming language, it's stored in the stack, and that way we can implement a recursive function. Then we can use it in several algorithms like DFS. So that is.
Yeah, so basically it's a data structure. So it is a list of data elements. Right? All other are also data structures or data elements only, like your queue and array. All these are data structures list. So the idea is, elements can be added or removed at one end of the list only, and this end is called the top of stack. And so there are two parts in a stack. One is top and another is bottom. So the idea is you push elements here and then you take elements from here. So what is actually happening? So it's not that there is a box that is being put in the memory and that is being used as stack. Is it happening that way? कोई मेमोरी में आपने बॉक्स ले जाके रखा है क्या, जिसको आप यूज कर रहे हैं इस तरह से?
No, sir.
तो क्या कर रहे हैं?
So can you repeat the question?
So when you are saying top and bottom, is there a box that has been put into the memory? What is actually happening by saying top and bottom?
So we are denoting the elements. We are denoting the memory address, which is the top or the bottom for that stack.
Yeah, so we are just defining some bottom address and we are using something called SP. What is SP? Tell me.
Stack protocol.
No, not stack protocol. SP is stack pointer. So a stack pointer points at the top of the stack, right? And the bottom element remains same, whatsoever it is, remains same means its location remains same. Top elements location keep on changing based on the data that you are pushing into it. So whenever you push more data, stack pointer shifts upward. When you will push further more data, it will go further upward. And when you are taking out data, so it will be going downward. So there are two operations that are generally performed while stack is being discussed. What are those two operations? Tell me.
Push and pop.
Push and pop. So what is push?
Storing an element in the stack.
Uh,
Like getting an element into the stack.
push means you are storing something into stack. And
Yeah.
pop, you are
Removing it from the stack.
removing and reading it from the stack. So you are not simply removing that, you are reading that as well. Right? So let's take an
Removing
example.
in the sense assigning to the, like suppose it's a function, then assigning it to what it's equal to.
Yeah,
That
and not only that, it's after that, from where it is you are reading, that portion will be actually not the part of stack anymore.
yeah,
So it's
point
actually
of view.
removing and reading both. Generally, what happens? Uh, either, I mean, you only read and write. Here, because stack is being represented using stack pointer, so that will not be stack, I mean, part of stack anymore. So just see a small example. So suppose this is a memory. This is a location where we are defining as the bottom of stack. And this is a location. Let's assume that SP is pointing out here. So there is a stack register, stack pointer. There is a register in processor that is called as stack pointer. Or SP, more commonly called as SP. So this SP points out, that means it stores a memory location. So for example, this is your memory location, let's say 400. Here SP will be having value 400. Right? And maybe bottom will be having a value of 800. So from 400 to 800, your stack will be there. Right? Is it okay? So if you want to implement the push operation, how will it be like? If I want to write a code for push operation, what I need to write? So first thing you have to subtract, because whenever you are pushing something, your stack pointer should go up, right? So first thing is you have to subtract the size of word length, and I am assuming size of word is 4 bytes, so 4 SP. So what you have to do, SP में जो भी वैल्यू स्टोर है उसमें से 4 कम कर दीजिए, यानी अगर यहाँ पर 400 स्टोर है तो इसमें क्या हो जाएगा, कोई बता सकता है?
400 स्टोर्ड है इसमें. 400 स्टोर्ड है सर। क्वेश्चन क्या है?
आपने सुना ही नहीं, शायद पूरी बात ही नहीं सुनी।
So when
हाँ?
hello. So when we're
हाँ,
actually putting storing a new value, so stack pointer it will be addressing to the topmost data. So
ये राइट,
400 minus 4 हो जाएगा.
400 minus 4 हो जाएगा। एंड व्हाट विल बी दैट वैल्यू?
Sir, like 396.
Is it 39? Will it be
Oh,
396?
no.
Hello.
So basically, like what I mean to say is stack pointer would now point to the newest element, which is at the top.
Right. But what will be the value then? What will be the value of 400 minus 4? So that will be, assuming that this is hexadecimal, and generally memory addresses are represented using hexadecimal. So that will be 3F. और क्या? Next बताइए. 3FC होगा क्या? हाँ? बोलिए। पहली बात तो ये समझ में आ रही है कि 400 माइनस 4 क्यों हो रहा है आपको? किसी कोई ऐसा जिसको ना समझ में आ रही हो? सबको आ रही समझ में? अब मैं ये कह रहा हूं कि हेक्साडेसिमल वैल्यूज हैं 400 और ये वगैरह, तो इससे जब 4 सब्ट्रैक्ट करेंगे तो उसको जब सब्ट्रैक्ट करेंगे तो 3FC हो जाएगा। अगर आप इन्हें डेसिमल मान रहे हैं देन 396 इज फाइन। अगर आप थोड़ी देर के लिए ये मान लें कि ये डेसिमल है, जो कि वो नहीं होंगे, देन न्यू डेसिमल। अब दूसरी चीज क्या करनी पड़ेगी? आपने स्टैक पॉइंटर तो शिफ्ट कर दिया, दूसरा क्या करना पड़ेगा? आपको वहां पर वो चीज भी लिखनी पड़ेगी जो आप लेके आना चाहते हैं। सो यू विल मूव whatsoever your XXX to SP. So this bracketed means you are using the contents of SP. ठीक है? Is it okay? पुश का ये ऑपरेशन समझ में आ रहा है कि नहीं आ रहा? हाँ या ना? बताइए भाई।
आ रहा है सर।
तो अब अगर आ रहा है तो पॉप के लिए आप मुझे बताइए क्या होगा ऑपरेशन?
सर पॉप के लिए 400 प्लस 4।
नहीं, ये जैसे आपने ये 2 लाइन्स यहाँ लिखी पुश के लिए, पॉप के लिए
Yes,
इस तरह
sir.
की क्या लाइन?
सर ऐड 4 कॉमा SP
You are saying
और
add
सर 4
4, SP।
यस सर।
और आगे?
और सर पॉप के लिए या तो प्रिंट कराना या फिर डिलीट, उसके लिए सर
डिलीट
पता
तो
नहीं।
होता ही नहीं बेटा कुछ। There is nothing like delete.
सर कुछ आउट, एस आउट कुछ उस टाइप।
ऑपरेशन तो वही होता है, मूव, लोड, स्टोर, ऐसे ही ऑपरेशंस हैं। ये ऐड डिलीट कोई ऑप्शन नहीं होता।
सर मूव XXX टू सम रजिस्टर।
मूव XXX टू
सम रजिस्टर सर।
सम रजिस्टर। ये XXX तो आपको पता ही नहीं है बेटा। यहाँ पे तो XXX आपको पता है क्योंकि आप पुश कर रहे हैं। यहाँ पे तो ये XXX आपको पता ही नहीं। तो this
सर
is
वैल्यू
not
एट द
move।
SP। सर पहले SP को लोड करना पड़ेगा रजिस्टर में, फिर उसके बाद उसको आगे करेंगे।
एसपी को क्यों लोड करना पड़ेगा रजिस्टर? एसपी तो आपका है ही वैल्यू, एक रजिस्टर ही है आपका एसपी तो एक।
सर एसपी जिसको पॉइंट
Yes.
कर रहा है वो मेमोरी लोकेशन से रजिस्टर में पुश कर मूव करना है।
आप बताइए, शुरू से बताइए क्या क्या लिखना पड़ेगा, पहले क्या लिखें?
हाँ तो सर फर्स्ट वी वुड डू मूव फ्रॉम मेमोरी लोकेशन वेयर एसपी इज पॉइंटिंग।
पूरा कमांड बोलिए, पूरा कमांड, पूरा इंस्ट्रक्शन बोलिए।
सर वो जो स्टैक पॉइंटर जिसको पॉइंट कर रहा है उसकी मेमोरी को एड्रेस करने का क्या है सिंटेक्स?
ऊपर नहीं किया क्या?
एक्स
एक्स तो
नहीं
कंटेंट।
मूव ब्रैकेट एसपी टू कॉमा आर, राइट?
ठीक है,
कॉमा एक्यूमुलेटर या कोई रजिस्टर।
ठीक। आप या मेमोरी लोकेशन में ले जाना चाहते हैं तो
ओके हाँ।
और
अब सर उसको क्लियर कर सकते हैं या फिर सीधे पॉइंटर को मूव कर सकते हैं?
क्लियर तो कुछ करते ही नहीं आप मेमोरी में, सो यू जस्ट मूव द पॉइंटर।
ठीक है, मूव द पॉइंटर, सो वी ऐड 4 टू स्टैक पॉइंटर।
Is it able to, are you able to understand this? हाँ, आपके समझ में आता है?
सर बट ये जो हमने वो किया, हमने सिर्फ पॉइंटर मूव कर दिया, तो सर अभी भी वो जो वैल्यू है वो मेमोरी में है ही ना, उसको
उससे क्या
कैसे
फर्क
फ्री
पड़ता है?
करेंगे?
आप जिसको एक्सेस करने जा रहे हैं वो तो अब वो वैल्यू नहीं रही ना। वहां पे जब किसी को कुछ स्टोर करना होगा तो वो स्टोर कर सकता है, स्टोर करने के लिए
ओके
मेमोरी
हाँ,
में नहीं।
ओवरराइट तब कर सकते हैं। ओके सर।
और कोई रीड करेगा तो वो इंश्योर करेगा कि उसने पहले गार्बेज वैल्यूज क्लियर कर दी हैं। आप क्लियर कैसे कर सकते हैं? मेमोरी को जीरो ही तो कर सकते हैं, इससे ज्यादा क्या कर सकते हैं? जीरो इज अनदर वैल्यू। तो मेमोरी में क्लियर करने जैसा कुछ नहीं होता। You only move the pointers or you read or write something there, right? ठीक है।
सर
अब हम पुश को ऐसे भी लिख सकते हैं चाहे तो, आप देखिए, चाहे मूव एक्स 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 माइनस एसपी। याद आया इसको देख के कुछ? ऑटो इंक्रीमेंट और ऑटो डिक्रीमेंट और पॉप को ऐसे भी लिख सकते हैं, मूव एसपी प्लस आर या R1 या लोकेशन, जो भी आप लिखना चाहें। ठीक है, ये दोनों इंस्ट्रक्शन समझ में आ रहे हैं?
Yes, sir.
अभी जो ऑटो इंक्रीमेंट और ऑटो डिक्रीमेंट हमने देखा था वो हो गया। अभी इसमें दूसरा प्रॉब्लम एक आ सकता है कि आप पॉप करते जा रहे हैं और स्टैक में कुछ बचा ही नहीं है। तब उसको अगर हमको इंश्योर करना हो कि ऐसा ना हो तो उसके लिए हम क्या करेंगे?
सर हम चेक करेंगे हर बार की जो स्टैक का बॉटम एड्रेस है उससे बाहर ना जाए। जैसे हम आपने कहा कि
तो एक कोड
पॉप
लिख
करते जा रहे हैं ना,
तो इसके लिए लिख के बताइए, कैसे लिखेंगे? लिखिए लिखिए।
मतलब वो इफ स्टेटमेंट बताऊं आपको कि कैसे ये स्टेटमेंट चेक करेंगे?
मतलब अगर हमको पुश और पॉप उस तरह से लिखने, ये इन कमांड्स को यूज कर लीजिए। और
हाँ
हमको ऐसे पुश और पॉप करने हैं जिसमें ये इंश्योर हो जाए कि हम कभी भी स्टैक खाली नहीं हो गया है, उसके ऊपर नहीं जा रहे हैं। तो कैसे करेंगे?
सर कंडीशनल स्टेटमेंट चाहिए होगी ना?
हाँ, कंडीशनल स्टेटमेंट लगाना होगा उसमें।
तो सर हम ये कर सकते हैं कि स्टैक पॉइंटर को माइनस कर सकते हैं और जंप इफ वो जो वैल्यू जो हमारे उसकी है वो करें तो जंप कर सकते
आपको उसके लिए यूज करना पड़ेगा इंस्ट्रक्शन, उसको कहते हैं कंपेयर।
कंपेयर। ओके
कंपेयर आपका जो भी वो है,
सर वो नेगेटिव हुआ तो JNC कर JN कर सकते,
वो
जंप
जो
इफ
भी होगा,
नेगेटिव।
मतलब उसका कोई ना कोई
हाँ
वो करस्पॉन्डिंग कमांड होगा, उसको यूज करके और आप कर सकते हैं। और इसी तरह से आपने अगर कोई अपर लिमिट रखी हुई है तो उसको भी आप देख सकते हैं कि इसके ऊपर स्टैक ना जाए, क्योंकि हो सकता है कि आप ऊपर जाते जाएं और ऊपर स्टैक जो है वो कहीं और किसी और चीज को प्रॉब्लम क्रिएट कर रहा हो। यानी आपने स्टैक डिफाइन किया है 1000 से 2000 तक का, और 1000 के ऊपर जो लिखा है वो आपने कुछ और लिखा हुआ है, तो उस कंडीशन में आपको वो भी चेक करना पड़ेगा। तो उसके लिए उन कमांड्स को हम बोलते हैं सेफ पॉप, and safe push. I hope you will be able to write that, so I'm not discussing that. ठीक है ये? ठीक है ये? Is it okay? स्टैक में यहां तक किसी को कोई प्रॉब्लम हो तो बताइए, नहीं तो हम लोग क्यू की थोड़ी सी बात करेंगे। चलें आगे? हेलो,
यस सर।
कितने लोग बचे क्लास में? खाली 38 लोग ही बचे अब क्लास में। हाँ? स्टैक और क्यू में बेसिक डिफरेंस क्या है?
सो ये फर्स्ट इन फर्स्ट आउट प्रॉपर्टी यूज करता है।
फर्स्ट इन फर्स्ट आउट क्या स्टैक की क्यू?
हाँ सर।
कौन यूज करता है फर्स्ट इन फर्स्ट आउट, स्टैक की
क्यू
क्यू?
क्यू क्यू।
तो ये तो एक प्रॉपर्टी हुई, इससे डिफरेंस क्या आने वाला है?
सर सपोज कोई, जैसे सर मैं एल्गोरिदम का एग्जांपल दे दूं क्या?
नहीं, ऐसे एक वर्ड में, एक लाइन में बताया जा सकता है कि इससे डिफरेंस क्या आने वाला है। इसमें एल्गोरिथम
तो
का
डिफरेंस है कि कोई एलिमेंट मैंने स्टोर किया क्यू में, ठीक है, तो अगर समझो ऐसे 5 एलिमेंट मैंने स्टोर किए, तो जो और फिर मैं अगर उसमें से पॉप कर रहा हूँ, तो जो फर्स्ट एलिमेंट स्टोर किया था वो आएगा मेरे पास। और वही अगर स्टैक में मैंने 5 एलिमेंट स्टोर किए।
इससे अंतर नहीं पड़ा ना, ये तो आपने वही बात पहले जो बोली वो दोबारा बोल दी। आप क्या करते हो, यहाँ पे एक एलिमेंट स्टोर करते हो, यहाँ से एलिमेंट निकालते हो, ऐसे ही
हाँ।
करते हो। जबकि स्टैक में क्या था, स्टैक में खाली एक जगह से एलिमेंट आ रहे थे और वहीं से जा रहे थे। तो यहाँ पे निकलने और रखने का रास्ता अलग अलग है। डज इट मेक सेंस? यानी यहाँ पर एलिमेंट आप रख रहे हो और यहाँ से निकाल रहे हो, ऐसे ही कर रहे हो। तो इसके लिए यहाँ पर खाली एक पॉइंटर से काम चल जाता था, जिसको आप स्टैक पॉइंटर बोलते थे। यहाँ पर आपको 2 पॉइंटर्स की जरूरत है, एक स्टार्ट पॉइंटर और एक एंड पॉइंटर, या एक बिगिन पॉइंटर और एक एंड पॉइंटर। एक तो ये इसके साथ दिक्कत है, या ये समझ लीजिए इसकी प्रॉपर्टी है। ठीक, दूसरा क्या इसके साथ प्रॉब्लम है? इसके साथ प्रॉब्लम ये है कि ये मूव करता है। आपने यहां से डाला, यहां से कुछ निकाल लिया, तो ये इट कीप्स ऑन मूविंग। आप यहां से निकाल लेते हैं, यहां से फिर और डाल देते हैं, तो ये ऊपर शिफ्ट हो जाता है। नेक्स्ट टाइम ये ऐसा हो जाएगा, फिर उसके भी नेक्स्ट टाइम ये ऐसा हो जाएगा। ठीक है ना? ये समझ में आ रहा है ना, ये शिफ्ट क्यों हो रहा है? हाँ, ये समझ में आ रहा है आपको कि ये शिफ्ट क्यों हो रहा है ऊपर?
यस सर।
इसके शिफ्ट होने से क्या प्रॉब्लम है? शिफ्ट होने से प्रॉब्लम है कि इट विल रिक्वायर अ लार्ज अमाउंट ऑफ मेमोरी, unless otherwise you are making some arrangement to that. So what will be that arrangement? तो arrangement ये होगा कि हमने जो भी मेमोरी इसके लिए डिफाइन की, फॉर एग्जांपल 1000 से 4000, हम इसको सर्कुलर उसमें करेंगे। यानी जैसे ही वो 1000 से 900 की तरफ जाना चाहेंगे, तो विल शिफ्ट ऑन टू 4000। हमारा नंबर ऐसे चलेगा 1000, 2000, 3000, 4000, 1000, 2000, 3000, 4000. ऐसा नंबर हमको चलाना पड़ेगा. So kind of circular behavior has to be kept while. So there are two things that has to be kept in mind while implementing the queue. एक ये 2 पॉइंटर्स लेके चलेंगे, दूसरा ये एक सर्कुलर बिहेवियर लेके चलेंगे, जो भी हमने इनके लिए मेमोरी एक तरह से देखा जाए यू एलोकेट की. मेक सेंस? अदर देन दैट क्यू और स्टैक में कोई बहुत अंतर नहीं होगा. तो निकालने रखने के तरीके एक जैसे हो सकते हैं, लेकिन 2 अलग अलग पॉइंटर्स के साथ. ठीक है ये?
Yes, sir.
ठीक है. अब आगे बात करते हैं सब रूटीन्स की. सब रूटीन आप सभी जानते हैं क्या होता है? सभी जानते हैं सब रूटीन क्या होता है? हाँ?
It's sort of like a hyper function used for a bigger
It's
function.
basically another name for function. जो आप सीमेंस को फंक्शन कहते हैं, उसके लिए एक हमको यूज करना पड़ता है कमांड जिसको हम कहते हैं कॉल. सब रूटीन का पर्पस क्या है? तो आपने यहाँ पर एक सब रूटीन कॉल किया. So you have written some line here, code of line here, code of line here. Then here you have written call. Let's say आपने 1500 call 1500 लिखा. यहाँ पर कुछ 1500 पे कुछ प्रोग्राम लिखा होगा. ये यहाँ से यहाँ जाके इसको एग्जीक्यूट करेगा, इस एग्जीक्यूशन को पूरा करेगा एंड इट विल कम बैक हियर. ठीक है ये? Is it okay? हाँ? ऐसे ही होता है ना?
Yes, sir. Yes, sir.
अगर ऐसा करना है तो हमको उसके लिए कुछ चीजें करनी पड़ेंगी. So it means it's not a normal branching instruction. It is little different. तो इसमें हमको क्या करना पड़ेगा, क्योंकि प्रोग्राम का हमको यहाँ पर वापस प्रोग्राम का एग्जीक्यूशन शुरू करना है. तो इसका जो भी यहाँ पर प्रोग्राम काउंटर का वैल्यू था, पहले उसमें ये वैल्यू स्टोर करना पड़ेगा, और जब ये एग्जीक्यूशन हो जाएगा तो उसमें दोबारा स्टोर करना पड़ेगा. यानी कि ये वाला वैल्यू प्रोग्राम काउंटर वाला हमको कहीं ना कहीं एक और जगह स्टोर करना पड़ेगा. जब सब रूटीन वापस आएगा तो उसको वो वैल्यू वापस मिलनी चाहिए. So there are 3 things that has to be done while executing a subroutine. First is store the contents of PC. दूसरा branch to target instructions, target address, जो भी कॉल में लिखा है. और उसके बाद जब पूरा एग्जीक्यूशन हो गया यहां से यहां तक आपका, ब्रांच टू अर्लियर पीसी एड्रेस. राइट? ठीक है ये? तो सब रूटीन का बेसिक एग्जीक्यूशन इस तरह से होता है. ये बात ठीक है? इसमें किसी को कोई डाउट है तो पूछे, नहीं तो हम आगे चलते हैं. हाँ? Is it okay?
Yes, sir.
अब सब रूटीन में 2-3 चीजें और हैं जो आपको समझनी चाहिए. हो नहीं पाएंगी. चलिए, तो अभी आज की क्लास में हम लोग यहीं तक रुक जाते हैं. नेक्स्ट क्लास में हम लोग सब रूटीन में पैरामीटर पासिंग और ये सब डिस्कस करेंगे. ठीक है? इज इट ओके?
Yes, sir.
ठीक. ओके.